repository, then we'll talk about data visualization, and then there's a very interesting demo that I want to sort of show you today. Last time we didn't had the hands-on kind of a demo, although this is also not hands-on in a sense that you'll not be working on it, but I'll share the notebooks with you so that you can work on it later. But the idea is this, that again, every week we're going to pick certain components of data science and machine learning and AI and sort of tell you what these components are, and sort of start the conversations around those components. Because again, if you're a teacher who is interested in sort of giving this information back to students, or if you're a student who is trying to learn these things, one of the biggest issue with AI in general is that there are a lot of moving components. By moving components, I mean that they keep on changing. So after 6 months, if you go on the internet, you will see that there's new things which are cropping up in the field of AI. There's new kind of learnings, new kind of algorithms, new kind of concepts. So it's very hard for anybody, whether it's a teacher or a student, to understand these concepts, because this is the kind of velocity it has in terms of what's happening in the field. At the same time, it also makes it very interesting, because at least you know that this is one of those fields where nothing is stagnated. Nothing is like, for example, if you think about computer science from a C++ perspective, everything is there. There's nothing new which is happening every day, or there's nothing new which is happening every 6 months or so. So this is one of the most exciting things about AI, that it sort of keeps changing month after month, and there are new things which are coming up. And this also sort of puts teachers in a very interesting position. And I use the word interesting because you also have to be very updated with a lot of things, because students are very fast. They will go on the internet, they will learn thousands of things, come back to you and ask for a lot of things. And this is what, if you notice in the last session also, we showed you certain things of how you can leverage new tools, new technologies, new resources during the classes. And in this also, we'll be talking about certain resources. So the combination of session is very simple, that we talk about new components, we talk about new resources which can be useful during the classes, and then we sort of show you certain examples where those examples are so easy to show during the classes that it will sort of help all of you to quickly learn and then sort of showcase them. So let's start with the first component, which is a big data. Now this is a very common word that we always hear, that there's something which is big data, there's something which we want to leverage in terms of AI. Now let's understand, what do we mean by big data? Because the data that we work, as in the classes, or when we do some basic problems inside Python and all, are those the big data, or what exactly is the definition of big data? So the standard definition of big data has different kinds of V's involved into it. So if you notice this thing, you will see that all of them has V associated with this. So this is why we typically call as 5V of big data, which sort of comes in terms of a definition. There are also 4V's, there are also 3V's, there are also 8V's, there are a lot of V's which are there. But the most important are the 5V's. So let's start with this. So the first one is the velocity part. So velocity is essentially speed at which the data is emanating and changes occurring between the diverse data sets. So what it means is, and we'll take examples of understanding this, is that the generation of the data has such a high velocity. And let's take a quick example to understand. Every day you do Facebook, Twitter, or any social media, you're generating lot of data which is sort of changing very rapidly. And this is what we mean by velocity. So we call something as a big data when the first condition is the velocity condition is checked, which is to say that the data that you're working on has a velocity. The second component is the volume component, which is refers to the volume of the data being generated. So typically, which is to say that if you're working on something which is like 100 MB of data, or maybe 2 MB of data, these are not what we typically refer to as big data. Big data essentially works in the in the area of GBs, petabytes, terabytes. These are the ones which we sort of refer to as volume. Now here's the thing, the issue with this is that most of the time during the classes you won't be able to work on gigabytes of data or petabytes of data. because it's not possible to work on these data sets. So ultimately you will be working on data sets which are either 2 MB or 100 MB. But it is very important that students should understand, and everybody should understand, that ultimate use cases of AI that we see around us and that we keep on quoting everywhere, for example, predicting the time it will take for you to go from point A to point B when you open Google Maps. These are these are calculations and models which are not happening on a small data. So it's very important to set the context with the students or everyone who is studying this, that it requires volume for you to do AI. It cannot happen in a small data, so which is very important. Then comes the third element, which is the variety element, which is that there are different sets of variety of a data that can be there. So roughly, we'll again talk about different types of data, but roughly variety means that you might have images, you might have videos, you might have text, audio, which again, if you think about any social media that you use, you have combination of all these things. So which is what we mean, that big data is something where we expect the data to have different varieties. We are not expecting it to have a single variety. So that is what we have in terms of variety. Then the fourth one is veracity. Veracity basically means that the data that you're collecting is being is very reliable and it's trustworthy. So for example, if you're collecting again the social media data, and let's say you're doing certain activities, those activities should be logged in properly into the data. Or if you were to use that data, and it sort of goes very counterintuitive also, in a sense that for example, when you want to do certain AI on a data, you need to make sure that that data is reliable enough, because you are going to build your models over it. So in a very simple term, the one which we use a lot in AI is that garbage in, garbage out. So if you put garbage inside the models, you will get garbage outside the model, right? So always we need to make sure that the big data or any data that we are using, and today we'll talk about how do we do that from a visualization perspective. And then the final one is the value. Value is again, something which is very inherent in the data, which is you might be collecting thousands and thousands of petabytes or gigabytes of data, but they should have inherent value in it. Like, there should be something that you should be able to extract out of it. If you're not able to do that, then there's no point of even doing anything on that in terms of collection, in terms of storing. So now once we see all these five different types of or five different V's of big data, like I said, it's very crucial for us to always understand that no AI problem in this world can happen without these five V's. You need to have these five V's, and this is the context of big data with AI. Because again, why we are trying to understand big data? Because we are trying to understand that how the whole thing sort of fits with the world of AI. Now, moving ahead, let's take certain examples of all of these things so that we get the idea. So, like we said, the volume is essentially the size of the data. So, for example, it is estimated that we'll be creating 40 zettabytes of data, which is 300 times from 2005, and which makes sense because everything that we are doing right now is on the mobiles, and those mobiles sort of generate good amount of data, so we will end up generating that much. Zettabyte is beyond petabyte. So you have gigabytes, then you have terabytes, then you have, so in a rough way you can say that 1000 MB is 1 GB, 1000 GBs 1024 GB roughly, but I'm sort of saying it to be 1000 GBs. Imagine 1000 GBs to be 1 petabyte, then 1000 petabytes become zettabyte. So you can imagine the scale that we are operating, and this is not future, this is what we are doing every day in the world, right? So that's the kind of scale that we are in. Now this scale is also very important for us to understand, because the future the future students, or the future people who will be working on AI, they will be working on these kinds of data sets. Like for example, when I work in the industries, we have these kinds of scales already. So we don't work on MBs of data, we work on terabytes of data, millions of records and things like that. Similarly, we have variety. So like we said, YouTube has sort of 4 billion plus hours of videos. Twitter has so much of text data. Facebook has combination of videos, images, and text. So you have so much varieties of data. These varieties of data, again, like I said, is important because you have specific way of solving this with respect to AI. So you need to know what is the type of data that you're solving so that you can use a specific AI algorithm. Any questions? Sorry.
No, sir.
Okay. Then we have veracity. Veracity is, like I said, the uncertainty of the data or the validation of the data that needs to be taken care, because unless you don't do it, you will not be able to build a scalable or a trustworthy model. So that's why, most of the organizations nowadays are doing this activity where they are trying to make their data more reliable, more validated, much more trustworthy. So this is another thing to think about. And then the velocity of it. Now, velocity, has a very good example of velocity, which is your Tesla car. So for those of you who remember, we talked about um, autonomous vehicles in the last session, and Tesla is one of those cars which is already there in people's hand, and they're driving it. And every day there are so many sensors which are generating data for each single car. So you can imagine that there are thousands of cars which are on road in the US, and each of the car is having hundreds and hundreds of sensors, and they are sort of generating good amount of GB worth of data every day. So that's the kind of scale we are talking about. Again, the whole idea of the big data with the AI context is to make sure that we are in the correct context of what is AI and what it deals with towards the end of the day. Like in the enterprises, this is what it deals with. Now, moving ahead, let's try to understand the type of big data. This is again a very common one where we have three different types, which is structured data, unstructured data, and semi-structured data. Now, structured data is essentially those data in a very simple language, the data that can either be in a CSV format or Excel format. Now, you might know what CSV and Excel is, but in a very simple way, if I were to put it, I would say that anything that you can represent in a table, your table, which is either on your Microsoft Excel or on your Google Sheets or any of those things, which has rows and column structure. So whenever a data that can be put in rows and columns, we typically refer to those as structured data. And this is why you see we have Oracle database, you have TXT files, you have CSV and Excel file, then you have a bunch of different databases which are available. So there are a lot of data which is like this, and all of this we are referring to as structured data. Again, let me give you another context of it. Do remember these types are important because each one of them have different AI algorithms which can sort of solve these kinds of problems. So it's not like you make a khichdi out of all of this and then you send all of this into a single algorithm. No, you have a very different way of solving each of the problem. So you need to understand what the type of the data you have. The second is basically unstructured data. Unstructured data is something which is you're very familiar with. So any kind of video, any kind of audio, text, these things are all unstructured data. Why we are calling them as unstructured data? Because typically you can't put a video on a row column format, right? I mean, video is like a different type of data altogether. It's not a row column format data. It's altogether a stream data. It has its own way of storing. There's a whole set of way you can sort of use it, not use it. But the idea is that unstructured data is a very different representation of a data. And you see this very often in all the social networking, whether it's YouTube, Twitter, Instagram, Facebook. All of these things do have a lot of unstructured data. And then finally, which is the combination, which is semi-structured data. Now, semi-structured data is something which, I'll give a very good example of it. Let's say there is a column one and column two, and we have, let's say, Lavi, and we have, let's say, Gurpreet. Now, column two, and let's say we have uploaded a video, right? And there is a link of that video in column two. So it's not a video per se, but it's a link to wherever this video is stored in some database. It could be a database where all the videos are stored. So this is also a link to that database. So this is what we typically refer to as semi-structured data, which is generally referred to as JSON structure. In terms of computing, we refer to this as JSON structure, but essentially the combination of sometimes when you include the unstructured data with the other structured data and combine them in a single representation, which is what we typically refer to as semi-structured data. Now, these, like I said, these all are very important types because they have different way of solving the problems, whatever problem that you have. So for example, if you're trying to do face recognition, face recognition will fall into unstructured data. It will have its own deep learning algorithm, which you will be using to solve it. Similarly, let's say you're trying to do fraud prediction. So fraud prediction is a problem which most of the banks do. So what banks are trying to do is they're trying to predict if any transaction people are making on their platforms are going to be fraud or not. So those data all fall into structured data, because you can imagine that each bank will have columns of data for each customers that they have, right? So I will have like 50 column data with some bank, because they would know my salary, they would know what kind of transactions I'm doing. So they have all of those things. So this is, again, for such kind of problems, you will do a different machine learning algorithm. And this is why this context is important, right? Now let's see some of the applications of big data. Again, these applications are not something very different from different from machine learning, but anytime we have used these in the context of machine learning, it has inherent implication that they are going to be worked out on a big data. So first, and these applications are also something which I've taken from a futuristic perspective. Like down the line, 5 to 10 years, you will see these things are going to happen quite often. So the first is communication, which is that by 2020, which we are anyway seeing, that person will own an average of 7 connected devices, which you can see nowadays because of the lockdown and everything. All of us are connected through laptops. The session is currently happening on through internet. So imagine that so many people across India, across globe are connected, and we are sharing information, we're talking to each other, influencing each other. So imagine that there's so much of data which is generated, right? So this data is another application which can be leveraged. I'll give you a very good example of it. Nowadays, many of the schools are leveraging this kind of a technology, where when a teacher says or teaches something online, it gets live translated, so that there is a script or the transcript associated with every lecture, so that if the student is not clear with something, so they get to see that. In fact, at the same time, when the students are listening to teachers, there are a lot of technologies in different schools where they're leveraging, where they're trying to understand whether the students were interested while learning or not. So these are certain things which can happen because of the connected technologies and the data that we have. Retail companies are generating huge amount of data. So nowadays, when you go and buy something on the buy something online, or if you buy something offline, all your data is being collected, and they are making it more and more personalized. So for example, if they know, which happens if you notice that if I go to any big bazaar or something, they know that I have entered big bazaar because they are tracking my information, and they can provide me with personalized offers and things like this, which is again something which is happening. The cars example is something we have talked about last time. So obviously there's so much of data which the cars are generating. Eventually down the line, 10 years, this will make the whole idea of traveling very safe, because all these cars are generating so much of sensor data, which then makes sure that you're not hitting cars, you're driving properly, or sometimes they drive themselves, so you don't even have to worry about it. It is also in the industrial sectors where they are generating huge amount of data, which again means that there's a huge potential of AI in those. And then finally, medical. So medical is again something you have started observing, that nowadays we have all these wearables that we wear, whether it's Apple Watch or Mi bands or anything, which is to say that imagine that your data, which was something which you had to go to hospital for. Like I'll take the example of Apple Watch, which recently came. It measures your ECG, it measures your heart rate, it measures your blood SpO2 level, and it measures VO2 max. So imagine these are the things which people had to go to hospitals to be measured, and now these are sitting on your hand. And imagine it's happening in 2020. Down the line, 5 years, we don't even know what might happen. Like they might do the blood test right away from our hand. It might be possible, which brings to the point that which it will generate huge amount of influx in the data, which will then bring us more and more applications of AI. And this is why students and everybody will be very interested in learning these kinds of technologies. Now, these are some of the tools which are very important and very well known in the world of big data. So Hadoop is one which is used for data storage. You have MongoDB, which sort of stores semi-structured data like we discussed. So this is one of those tools which can store semi-structured. Same goes with Cassandra. You have rapid miner SPSS, which is for mining that data. So once you have the storage, you then have these tools that can extract those things. Then you can do analytics. So one of the well-known name is Spark. Spark is one of those open source tools which is used in enterprise a lot. Like our day-to-day work happens a lot on Spark because it has a capacity to do analytics on terabytes of data in seconds. And I'm not kidding, this happens. So we have so many things that we do a day on day basis where we churn out this much of a data. And then the visualization tool, again, we have Tableau, we have Looker, we have Power BI. These are all tools which are, again, not something which students will be using, but they should know that these are high level tools which sort of exist in the market. Again, this is a scale that we are talking about. So this is again slightly older. I think this is 2018, if I'm not wrong, or maybe slightly older than that. But it is the kind of data that we are generating. So the whole point of whatever we have discussed so far is that it looks very promising from the AI point of view, because the more you generate, the more it is a requirement that you need to do something with it, right? You can't just sit with so much of a data, which is to say, this is why the first statement that I said, which is there is a huge scale of innovation that is happening in AI. This is the reason of that innovation, because people are really worried that we are generating so much of a data. We need to, extract something. This is why, I don't know if you have heard this or not, a lot of people refer to this as data is the new oil. The reason we are calling data as the new oil is because the next century will be driven out of this oil. I mean, the previous century was all about the oil, which then created the whole industrial revolution and all those things. We were able to create machines, we were able to create transport systems. So see from last century how much advancement we have done. Now people say that data is that new oil, which is to say the next century will be driven with the data, and which is true also, because you're able to see the implications of those so far. Now, this is something that I've already talked about, that machine learning, AI, whatever we talk about, it is that big data which is basically fueling all of this. So never forget that ultimately it is those big data that has to be incorporated if you want to sort of do something which is more promising. Now, obviously, like I said, I understand from a practical point of view, we can't really use big data in a class, but we should be aware that we should keep on, telling students or in general that there is a component of big data which needs to be understood properly in that sense. Now, before I end this, there is one very important data science cycle, which again, like I said initially, that in the coming sessions, we will be exploring more components out of it. But essentially, if you see the whole data science cycle, and let me sort of walk you through this basic thing. So the whole data science cycle starts by understanding the problem. So this is very simply saying that you try to understand what is it you're trying to solve, and then trying to see whether you have data for it or not, whether client has or what is the expectation of a client, or what are they going to get out of this. And then we do the second step, which is the data acquisition and understanding, where you have data sources. So you get to each and every sources of the data. You build pipelines to make sure that your data is coming right to your environments where you have all the Python and everything that you're going to work. Then you have wrangling, exploration, and cleaning. Of this, cleaning is essentially just making sure that your data is reliable enough to be passed to model. Exploration is where you try to explore the data and get insights out of the data, and this is what we'll do a hands-on today, so that you will see that eventually the whole cycle of data science will be explored in the sessions, and we'll sort of talk about those things. Last time you saw the deployment part, which is, creating a dashboard, running the model on a web UI and things like that. So you were seeing the deployment path last time. Modeling we have not yet decided so far, but eventually we'll also see, we'll show you some basic models, how to build that and things like that, because there are a lot of components inside those as well. So you have feature engineering, model training, model evaluation. So we'll sort of talk about what these, but essentially if you see, this is the most important aspect of this, is that this is a cyclic process. By cyclic process, it means that it might start and it might go back to the step one, and it keeps on doing it unless you solve the problem. So it's not a sequential process. It's not like once you start and then you build a single stream of model and then you're done. No, it sort of keeps on going, because there are so many assumptions, so many things that you have to do. This is why, if you remember last time I said, the word science implies that this is an experimentation. See, we use science word very importantly. Why? Because it simply means that you're trying to do different experiments, so many experiments, such that ultimately by the end of any experiment you might prove a hypothesis. Like for example, in chemistry or physics, this is what we do. For example, in physics, if I have to say the gravity is 9.8, for example, if this is the number that I need to prove, I need to do a specific experiment 10 or 20 times, and then I do the average of that number, and I say, all right, the hypothesis was that the number is 9.8, and I've done 10 experiments that shows that this number is lying between it, and finally the average is true. This is exactly what we do in data science. So you have a hypothesis. Your hypothesis could be, I want to predict fraud, I want to predict this, that, whatever you want to predict. But the whole idea is that, you do multiple experiments, right? So this is what we have in terms of the data science cycle, and something which, you should remember, that this cycle is very important. Nothing happens in data science if you don't follow this kind of cycle. Now, obviously, like we discussed that, there are the big data is something which you should always be aware of. So what I have done is I've sort of included some open repositories. So when you get the slides at towards the end, you can sort of go through these links and you'll be able to see. I've given you the link of all these things, so you can just go to this link and access all of these. I'll also talk about Kaggle, but before this, you can see that this is a data which you can refer to as big data. These are not small data. These are not like 1 MB, 2 MB. But the idea is for not for you to sort of just go and download and start using it, because you need a very strong environment to support that. But the idea is for you to go and see what these data look like see how a GB worth of data looks like, or see how a terabyte data looks like. And this is why these links are important, so that at least you'll be aware of what in this world is available for you, just so that you can use tomorrow and start working on it. One example that I will cover is this, which is CT cancer medical images. I'm not sure how many of you know this, but there are so many data which is available of cancer patients, which is basically your CT images, your X-ray images, your blood reports. Now imagine this all data is available for free. Obviously, it's not small; it's very big data. But the potential with this is that any kid tomorrow can just download it, if he or she has that system to support, and they can actually start building models out of it. And I'm not kidding, people have done this, students have done this. They have built models just to predict certain things in the cancer world or things like that. And it is now so easy for people to do it, and this is why I want all of you to go and check these repositories, because you might come up with some some different ideas of solving a problem. Your students might come up with different ideas of, maybe let's use this to do this kind of a thing. And this is why I'll stop this with Kaggle. Kaggle is one of those websites which, if you don't know, you should really make it a part of your classes, because Kaggle is like that platform where there are a lot of business problems, fun problems, problems which are hosted, where you have a data, where you have all these steps that needs to be done, and millions of people across world. And I'm not kidding, there are so many people from companies, from schools, from colleges, everybody is sort of doing some problem solving there. So it's a competitive programming thing, but it is focused only for data science problems. So What you can do is you can leverage this in your classes. You can take problem statements which are there, which are real world data, which is available there. There are many fun problems in all domain, whether it's medical or any other kind of things. They're all available there. You can just download it. If let's say you don't know how to solve it, people have put up their codes, people have put up their end-to-end code, so you can just go through and see what they have done. So it's a complete open platform. It's a wealth of knowledge. In fact, people who are coming to data science industry, one of the very important thing that we always see whether they have done anything in Kaggle or not, because it's really more than their undergraduation graduation, because at this point we don't have that much that much things in those areas, but we generally check Kaggles and things like that. Now we come to visualization. So like I said, of all the components, we're going to talk about some basic components in each session. Now what I'm going to do is, again, let's first understand why is data visualization important, because like the whole idea is to convey information through visual representation. And what is that information, right? So what we'll try to do is we'll try to understand, what do we mean by that and how do we use it. So what I'll do is, let me stop this. Let me go to, all right. So can you tell me if you can see the notebook?
Yes, sir.
Okay, perfect. So what I wanted to do in this notebook is, and again in the presentation you have the link. For those of you who don't know what Google Colab is, Google Colab is, think of it as online hosted version of Jupyter Notebooks. Again, for those of you who don't know what Jupyter Notebook is, it is one way of doing coding, which is interactive, which is not like you're doing coding either on a terminal or on IDEs that you typically do. So it functions like a book, wherein you can write a code. So for example, let's say, for those of you know basic Python, let's say I want to do 3 plus 3. I can write that code and I can just run this, and this is all happening on the internet. So all of this is nothing on my laptop. This is all online, and you can sort of share it with people, which is the most amazing thing, because now whatever I work on, I can directly share it with you. So the beauty of these notebooks in general are that you can code something and you'll get the output next to the cell. So you don't have to do, write the whole code and then run something and then wait for it. So this is, again, for those of you who don't know what it is, for those of you who know, this is just the online hosted version. This is Google's product. So you have to sign in with Google if you see and want to sort of access the notebook that I have done. Now, what I've done in this notebook is very simple. I have a Titanic data set. So let me show you the data first. This is the data. So this is, again, all of you know what Titanic is. It was a ship which drowned and we had a movie on it. And it's something which, all of us understand very well. So this data is essentially that data where each row represents a detail of a passenger who traveled on Titanic, and we know whether they survived or not. So zero means they didn't. Sorry, one means they didn't survive. Zero means they did survive, right? So what we are trying to do here is we are trying to sort of see what all we can. Oh, sorry, let me put this here. So survived is one and died is zero. Okay, so this data is essentially a data which sort of talks about that whether this passenger survived or he died, he or she died during the process. So you know the person's name, and again, one thing which is very interesting in this data is that each is not a single person. Each is a ticket. So each ticket could be of a family. Maybe 2 or 3 person might be traveling with this. So for example, these are two people, because if you see siblings and spouses is one, which is that he was traveling with his, probably with his sibling or his wife, and there are no parents and children. So if they were, you will get one or two or three, how many numbers they are. So what we are seeing is whether the whole ticket survived or the whole ticket sort of drowned during the process. Now, now we have the name, we know their genders, we know their ages, we know whether they are accompanied with siblings or spouses, we know whether they were accompanied with parents and children's, the ticket numbers, how much fare in pounds have they paid, the cabin number, and the embarked. Embarked is basically port from where they have taken the Titanic, just like train stations or airports. So this is the data. Now in this data, we have already seen that whenever something can be put into rows and columns, it typically becomes a structured data. So this is a structured data which we are trying to handle. The goal of this data is simple, that can you predict that who will survive and who will drown the Titanic? So this is like a hello world data of machine learning. You will see a reference of this across many different introductions. In fact, a lot of you might be very familiar and you might have done a lot of things around it. So what I want to show in this is that how, from the industry point of view, in a very minimalistic code, which will make a lot of you very happy, we can do so much of the visualization in a single go. Now for that, what I'm going to do is I have loaded the data from a GitHub, and I have a couple of libraries that I'm loading. Again, for those of you who are not aware of Python, you can just see how things are, and there are a lot of sessions we Gurpreet Teams does every week. So you can sort of attend that, and this will start making sense. So we are loading certain libraries. One of the most important one is pandas profiling. Now what that does is very promising. What it does is it creates a report, and let me first show you the code for it, because the point that we are trying to see is how much can we create with the minimalistic code. So if you see the code, all it does is I'm calling a profile report, I'm passing the iframe, and I'm sort of saying that just create a data profile of my data. And then finally, I'm creating an iframe. So you see there are two lines of codes, and these are again something when you go and understand, these are very straightforward code. And then it produces a report like this. Now this report is a report of your data, just like a report card of a student. This is a report card of your data, where it tells you what are the number of variables, number of observation, how many missing values do you have, missing cells in sense, how many percentage of missing values. Because again, see, we talked about in the big data that it's very important for us to have a validated data, or a data which is sort of um, which has truthfulness into it, right? So when you have missing data means there are some data points which are not available, which is not good for us, right? So this is what we get as a report. We understand. Now the other beauty of this is it generates for each column a graph that you can see and understand what this data is all about. So let's take the survived column. If you see it, this report tells us that there are 342 survivors and 549 dead people. And it makes sense, because when we have seen the movie Titanic, we know that there are a lot of people who died and there are very few people who survived. So this makes complete sense. But the beauty is you never had to write a code to see this graph, right? You just did one single report and it gave you the whole idea of this. So you can now see distinct count as to missing values. So there are no missing values in survive. So we are happy. There's good unique details in it. You can toggle detail and you can go in more detail and sort of understand a bit more detail, like exactly what is the percentages of these records. Now, very similarly, you can see P class is just like, we have sleeper, AC1, AC2, AC3. They also had classes. So you can see that we have three, third is the lowest class, one is the higher class. So you can see that there are a lot of people in Titanic which are traveling through third class. Now, here's the thing. This is a very funny thing. If you remember the movie Titanic, you would know that the first people to die were the people who were at the bottom of it. And at the bottom of the ship, there was third class. And this is why you see there are so many people in the third class. And it would be interesting to see this correlation and check in the data whether this actually makes sense or not. Like, is it the people who died, which class do they belong to most? And we'll draw one graph to sort of showcase that. But that's the whole idea. So you can see that we have a graph for age. Again, you didn't draw it, you didn't have to write a code, but the report generated it for you. So you can now very clearly see the representation of the data. So you can see that there are 88 distinct. You see how many. So in this, you can see that there are 177 records which are missing, which is almost 19% of the record. This is not good, right? So even before going to the model without running any code, you were able to see these kinds of things. You get to see the mean of the data. These are certain statistics, which is very important. Again, as part of AI, if you remember the last session, we talked about that data science is nothing but a combination of statistics, mathematics, and so on and so forth. So we do want to understand certain statistical property of a data. So min, max, zeros, memory size, the memory size is with respect to the column. But nevertheless, so this is what the report says. Now I would request all of you to go through this and see what the report contains and see the power it has, because it sort of gives you so much information with just a simple just a simple code. This also contains correlations, so you can actually see what is the correlation of, for example, P class with survive. So let's check P class survive, and if I see the color coding, it shows somewhere between minus 0.25. So it's a negative correlation, which again makes sense. Negative correlation means higher the class, lower the survival rate, right? Higher means if it is 3, you will have lesser survival rate. So which makes sense. So there's a 30% negative correlation into those things. And again, like I said, this is something which which you never had to write a code for. It has all been given to you just by writing a single line of code. Now let's quickly, before we end for today's session, let me show you two more representations. So like I said, I wanted to see whether there's a correlation between survival and the classes that they are traveling on, right? So for that, what I'm doing is I'm using matplotlib, which is a very important library in Python to create graphs. What I'm doing in this is I'm simply writing a function. Functions are those wrappers where you don't have to rewrite the code again and again, and you can just call them again and again. So you don't have to. So for example, if your code involves like 5-6 lines and you have to rewrite them again and again, so functions are those wrappers which can sort of wrap everything around, and you don't have to call the whole lines, and you can just call a single line and it'll do your work. So in this function, what I'm saying is just tell me the feature you want to plot, and I will calculate the survived and the dead. So survived is 1, non-survived is 0. And then I'm just simply doing a df.plot. Again, I'm not going in detail of how this plot was created, because the intent is not this. You will see all of these in the Python sessions which are happening, but the intent is to show you the power of these visualizations, like how can you get to a information or the insight quickly. So I'm just plotting this, and I'm saying I want a bar plot, and this should be stacked, and this is the figure size. I'll show you what stacked is. Now what I'm doing is I'm simply, see, this is what the beauty of functions are. I can now just call this line again and again, and I don't have to write them multiple times. So I'm saying, please plot the P class and show me the graph of it. So you see, I just called this, and there you go. This is the graph. Now, what it is showing us is a very important information, which is what we have seen in the movie also, which is, if you notice, who are the people who are surviving. If you see from the distribution, you will notice that the blue has a higher distribution. If you go to the legends of the graph, you will see that the blue is 1, which is higher class. Again, this makes sense from a movie point of view, because in movie, people who were rich enough, they were at the top, and they were actually running away, even though as a management of the ship decided the women should go first, women and child. But there were so many people who were so rich enough, they actually gave money to people just to sit on the boats and things like that, right? So this again shows the same thing from the graph itself. And the opposite of it, if you see the deads are of class 3, which makes sense. See, this is what we said, right? Our hypothesis was that people who are traveling through third class, and I'm not saying they're poor, I'm just saying that in terms of hierarchy, they were at the lowest in terms of ships. So when the ship hit, they were the ones who were dead first. And this is what it shows from the graph as well. And this is the power of visualization. See, again, think for a moment, what did we do? We loaded the data, and we just wrote bunch of 3 lines of 5 lines of codes, and we were able to confirm our hypothesis. And hence, this is why I said this is what data science is all about, that you have a hypothesis, you prove it with data, you prove it with visualizations, and that's what it sort of helps you do. Now, I'm just going to show you the last graph just to sort of give you a heads up that there are so many powerful graphs beyond the graph that you just saw, which are interactive also. So there's a library called as Plotly Express, which is built over Matplotlib. And you can see I'm just writing a single line. I'm saying I want a scatter plot, and I just want these 5 columns, and they should have been colored with the survive. Now, if you come down, you will see that it gives me an interactive graph. Why am I saying this is interactive? Because I can see the quotations of the data. I can see live who survived and who didn't, like what section of data survived and what section of data didn't survive. In fact, I can just select something and I can say, all right, this is the data where it seems like a lot of people have survived. And I can see the age of those people. I can see what is the variation of age and things like that. So this is very powerful. And if you see the amount of effort it took to draw that, very minimal, right? It's just a single line of code where you just had to mention, this is my data, these are the columns I want to sort of see, and please filter everything with the color, which is the survived, the class that I'm interested into. So that's the whole idea. So again, I will stop here. Like I said, I want to conclude by saying that the idea of the session was to show you different components of AI, including this, which is big data, and how visualization plays a crucial role in doing anything related to AI. So that's all from my end. I'm open to questions.
So we have 5 minutes for the Q&A session. Those who want to ask
Uh,
anything,
Good
yes,
teacher, I just want to add one or two statements over here for
please,
the
please,
teachers.
please.
Um, Good evening, everybody, and thank you, Lavi, for such a great presentation. It was very well explained, and thank you, Gurpreet sir, for the same platform every single time. Apologies for not being able to make it to the session for participation part today.
Wonderful.
This is just one heads up to all the teachers who are teaching artificial intelligence in grade 10th specifically. Reasons being that we are always looking for resources when it comes to the Python component of our theory paper, or for the practical component for the 50 marks that we look for in our paper. This activity that you have just seen right now is one of the activities that can be done with the students, and the students can be asked to create these kind of notebooks which can be put up in their practical files. So this actually helps us come down to zeroing down to those projects which we are looking forward for CBSE or otherwise also. So very well explained, sir. Thank you so much for such an informative session.
Yeah.
Thank you, Amit.
Thank you, Arneet ma'am, for pitching in. Thank you so much, Lavi sir. We have been receiving wonderful responses in our chat box for today's session as well as the last one. People are looking forward for more one from both of you. And you rightly said, with every passing session, with every new session, our knowledge base and inclination towards your session is increasing. So I must congratulate Lavi sir and Arneet ma'am for that. And it was an amazing fact that this TBs of data is being analyzed in a few seconds through these things, Hadoop and the Spark one that we have shared. It's really amazing. And yes, we have been hearing, we have been reading about the data is the new oil. We have seen in the past a lot of wars and political concerns happening over the dispute of oil. And the ones who are having huge amount of oil, they are rich enough now. The trend is shifting and we are in this era of data, rather big data. Yes, certainly the next big thing is data only, and the countries, the places, the people will be having more data security and good capabilities for data analysis will be moving towards that richness concept. So thank you so much for such a wonderful session. And on behalf of every participant, thank you from the core of our heart for sparing your valuable time and sharing the experience that you have gathered over the period of time. We are grateful to you and we look forward having so many more sessions from Lavi sir and both of you.
Hello, hello,
Ma'am.
hello, sir. This is
Thank
Jatin.
you.
I just have a small question, if you don't mind.
Yes, please, Jatin, go ahead.
Yeah. So, recently, as recent as like 2, 3 days ago, I was just going through an article wherein Sachin Tendulkar had, given a reference where I had heard that Bitcom, which is one of the money-making machines, so-called money-making machines nowadays, is using AI and machine learning to, calculate the profits, or wherever we put in money, they can invest that money. So can you shed some light on how important AI and machine learning is in terms of uh, taking out these possibilities of gaining profit when it comes to Bitcoin, or these kind of areas where people are investing nowadays, and how true is that?
Thank you. I think you mean Bitcoin, right?
Yes, sir. Bitcoin.
Okay. Okay. Wonderful. So basically, it's partly true and partly hype, which is to do with every new technology that comes in. So we should take all of them with a pinch of salt. Not to say that they are not, it's not possible to do these things, but they are at a very early stage at this point. There are many companies who are investing money just by algorithms, which is to say that the algorithms tells us that, all right, invest in this company with this much exposure and you can expect this much return, or they optimize your portfolios. For example, if you do mutual funds or if you're buying stocks and things like that. So there are definitely a lot of companies who are into it, they're doing it, not not to the extent of hype which is generated, like I said, which is very common. It happens with every technology, but there's a great future in these things, Jatin. So I think down the line, 5 to 10 years, we will have automated investment, products which are going to come up. In India, we have some companies who already have those products, but in future we will see a lot more, which will help us be more proactive in terms of investment. It will help us reduce the risk, which is the biggest issue with investment, is that sometimes you have no idea when the stocks are going to go, like for example in the COVID scenarios, like um, so this is the whole idea. So yes, there is a hype, there is a truth to those things. People have done it, people are doing it, but it's going to take a lot of time to be mature enough, at a level where we can just say, all right, now nobody from a human world does investing, it's just the algorithms and computers. So I think that is going to be next 10 years or 5 10 years.
So currently, just to add on, currently, is it safe to say that from an investment point of view, I know it's probably it's not with reference to what you're talking about, but is it actually a safe bet in today's time to probably rely on AI and ML, while you're saying it's 5 to 10 years when we can probably be very sure about it? Is it a good bet to invest in Bitcoin at this point in time, depending on AI and ML? Machine
I
learning?
don't think so. I think, see, when you say should I trust, I would say you should if you are a person who understands the technology of AI as well as the Bitcoin, and you understand the market how it operates. Then I would say you can trust. But if you're, let's say, I am a person who has no idea what the market, how the market functions. So for a dummy person like me, I should not trust it. So this is the whole idea, that if you're somebody who understands both the technology and the market, you can trust it. If you're not, if you're dummy, or if you have no idea and you just want to spend money, or if you just want to invest money, then just wait for some more, I would say 5 to 10 years down the line.
Right. Thank you so much, sir. I really appreciate it. Thank you.
Thank you.
Gurpreet sir, you are on mute.
Thank you, ma'am. Sorry, I was on mute. I was thanking Lavi sir and Harmeet ma'am once again, and to the participants at the next session, the coding club session, Python session number 8 is is at 6 p.m. and I'm just going to share the link here in the chat box. I've shared it. You can join using this link, and I've shared the same link in the WhatsApp group also. So see you at 6 p.m. for the Python session. And once again, I'm grateful to have Lavi sir and Harmeet ma'am for these wonderful, wonderful sessions. And we look forward having many more sessions with you.
Yep. Thanks, Gurpreet, for hosting, and thanks
Sir,
everyone.
today's Python section is on which topic, sir?
Python only, ma'am. It's a series of sessions. Python, it's a 8th session today.
Okay, thank you, sir.
We probably wanted to have a specific out of that. So that was on variables. We discussed variables last time, and we'll be continuing from there. So, right. Thank you so much.